Let's explore the hemodynamic source code of human physiology. By auditing the neurovisceral integration between the brainstem and the heart, we can reverse engineer the precise mechanisms behind breathwork. Note the blue parasympathetic pathways interfacing with the cardiac pump station. This is where conscious control meets autonomic response. Think of this translation layer as a bridge between the abstract and the empirical. We're taking subjective wellness concepts like opening the heart or grounding and stripping away the spiritual overlay to reveal the underlying biological mechanisms. By running these signals through a recursive mechanobiology filter, we can map them directly to physiological source code. We're not just talking about emotional release. We're talking about maximizing baroreflex gain, synchronized modulates, and optimizing afferent vagal modulation. This is where spirituality meets clinical engineering. Baroreflex sensitivity, or BRS, is a critical metric of hemodynamic efficiency. While often mistaken for a mood, coherence is actually a measure of how effectively your heart rate adjusts to changes in systolic blood pressure. By calculating the ratio of the interbeat interval to blood pressure, we can determine the gain, or responsiveness, of your autonomic system. A higher BRS translates to greater autonomic resilience, whereas a low BRS indicates a rigid, less adaptable system. Ultimately, we aren't just relaxing, we are actively expanding the dynamic range of the body's internal braking system. At the biological hardware layer, we utilize piezoelectric transduction to bridge the gap between mechanical pressure and electrical signaling. Piezo 1 channels, located in the vascular endothelium, sense fluid shear stress to trigger essential nitric oxide release. Simultaneously, Piezo 2 acts as our primary vagal brake sensor in the carotid sinus, converting rapid mechanical transients directly into neural firing. Together, these channels serve as the critical transducers that transform physical forces into the biological data streams driving our translation protocol. Think of the intrinsic cardiac nervous system, or ICNS, as the heart's own local brain. It operates as a distributed computing network that's remarkably independent of the central nervous system. This architecture allows the heart to process complex sensory data, like chemical changes and mechanical stretch, and coordinate reflexes in real time. Most importantly, this system exhibits plasticity, meaning it can be trained to optimize performance, making it a critical frontier in clinical engineering and bioelectronic medicine. Meyer waves are the fundamental carrier wave of the human vasculature. These spontaneous arterial oscillations occur at 0.1 Hz, or exactly 6 cycles per minute, rhythmically swinging between sympathetic vasomotor tone and physiological relaxation. Because this frequency is a stable biological constant, it represents our internal system's resonance frequency. Achieving peak physiological optimization often depends on our ability to align with this primary circulatory rhythm. To optimize the system, we use a technique called the hack, achieving hemodynamic resonance through frequency matching. By aligning our respiratory input with the body's natural baroreflex rhythm, both at approximately 0.1 Hz, we create constructive interference. This results in phase locking, where heart rate variability and blood pressure oscillations reach their maximal amplitude, driving the system into a state of peak physiological coherence. Let's look at the uplink, the primary highway of our internal communication. Notice the massive bandwidth disparity. 80% of vagal traffic is afferent, streaming data from the heart directly up to the brainstem. This bottom-up signal carries critical telemetry like pressure rate of change and mechanical stretch. Ultimately, you cannot simply think yourself into a state of coherence. You must force that signal up from the chassis to optimize the system. The vagal brake is our primary mechanism for optimizing physiological stability through frequency matching. It begins when high-amplitude afferent traffic enters the nucleus tractus solitarius in the medulla. After integrating this cardiorespiratory data, the NTS sends a targeted vagal signal upstream to mechanically inhibit amygdala firing. This effectively downregulates the reticular activating system, serving as a manual override of our threat detection software to restore systemic balance. Our cognitive performance is fundamentally tied to our physiology. This model illustrates the vital connection between the body chassis, your heart and lungs, and the executive command center of the prefrontal cortex. This link is governed by the vagal brake. When this switch is engaged, we achieve resonance, bringing the brain online for optimal emotional regulation and working memory. However, in threat mode, that brake fails, shifting us into a reactive state. To perform at our best, we must maintain the neurovisceral coherence that keeps our executive functions sharp. Moving beyond generic techniques like the 4-7-8 method, the resonance frequency audit is about biological precision. Our objective is to identify your individual system clock speed. By accounting for your unique vascular loop delay, we can pinpoint the exact breathing rate, typically between 4.5 and 6.5 breaths per minute, that maximizes the amplitude of your respiratory sinus arrhythmia, effectively tuning your system to its optimal resonance band. To calibrate our biofeedback loop, we begin with the pulse detection audit. Using your tactile pulse as the sensor, synchronize your breathing to a steady 6 breaths per minute. Notice how your heart rate naturally accelerates as you inhale and slows as you exhale. By micro-adjusting your pace between 5 and 7 seconds, you can locate your personal sweet spot, the exact resonance frequency where the delta between these two states is at its absolute maximum. Forget the vague notions of manifesting peace. The Rational Psychonauts Manifesto reframes self-regulation as a rigorous engineering challenge. We treat the heart as our biological metronome, phase-locking respiration to Meyer waves to achieve peak hemodynamic resonance. By precisely modulating our cortical signal-to-noise ratio, we move beyond simple mindfulness into total system control. It is time to audit your source code and take command of your biology.